Okay, so this is basically just an active recall of proof of the first isomorphism theorem. So you have to recall para hindi malimutan and to solidify the steps. So what is the first isomorphism theorem? What is it? The first isomorphism theorem of groups. So basically, you have two groups, G and H, diba? And then you have a homomorphism between them. So F is a homomorphism. The first isomorphism theorem states that the image of F is isomorphic to G mod kernel of F. So that's actually what do you call that? The statement for the first isomorphism theorem is. So let's go back. So again, if F from G to H is homomorphism of groups, then F induces an isomorphism. G mod kernel of F is isomorphic to the image of F. But actually, this result, first isomorphism theorem, is simply a corollary or direct consequence of factor theorem. Factor theorem. So what does the factor theorem say? So factor theorem basically, this is just a guess, but I think I'm right. Maybe I'm right, maybe I'm wrong. So I think it's called the factor theorem because you factor the function f into a composition of two functions, f bar and pi. Pi here is the canonical isomorphism. That is an element A of G is mapped to its coset, basically. So let's look at that. What does it look like? So instead of dealing directly with F, the factor theorem actually goes through this first G mod n. This n here is a normal subgroup of G. So G to G mod n, we have a map pi, what is called the canonical epimorphism. It's an epimorphism because it's a homomorphism that is surjective. So, ganon. Yan, si pi is a canonical epimorphism. So, A is mapped to its coset, AN. So, this is surjective. And then, actually this is where the brunt of the work is, showing that this function f bar, definition of f bar is the coset an is mapped to the image of a under f. So from G mod n, we have an and then mapped to the image of a under f. So we have to show that this is a homomorphism. Okay? G mod n to h. We have f bar. Okay? And its definition is that coset an is mapped to the image of A under F. So we have to show that this is a homomorphism. I always forget that you have to show that F bar is unique. So if F from G to H is a homomorphism of groups, and N is a normal subgroup of G contained in a kernel of F. N is a normal subgroup of G contained in the kernel of F. So N is normal in G. And N is also contained in the kernel of F. What does kernel of F mean? We'll define that later. And then there is a unique homomorphism. I always forget this unique part. So it has to be unique. The homomorphism F bar from G mod N to H defined by, so AN is mapped to the image of A under F, right? So you have to show that this mapping is unique, and you have to show that this is also homomorphism. Homomorphism is actually quite simple. It follows from the homomorphism of F. Uniqueness maybe not as simple, but anyway, let's see. Another thing is you have to show that the image of F has the same image as F bar. Next, that the kernel of F bar is equal to kernel of F mod N. And then finally, you have to show that F bar is an isomorphism if and only if F is an epimorphism and N equals the kernel of F. We actually prove it in two parts. The first part is F bar is an epimorphism if only if F is an epimorphism. Second part is F bar is monomorphism, meaning an injective homomorphism, so one-to-one homomorphism if and only if N equals the kernel. The whole of N is the kernel. So, diba, N is contained, so we have the kernel, say this is the kernel of F. N is subset, so belonging here. This F bar is one-to-one if the N is a whole of the kernel. Parang ganon. Anyway. So, before you can prove that, you have to ang tawag doon, define some terms. Define some terms. What terms? Terms. First of all, kernel of F. What do you mean? Or start with the homomorphism. So we have a mapping F from G to H, a mapping of groups. So when can we say that this F here is a homomorphism? It is a homomorphism. It preserves operations in H after applying the function or the mapping. So basically, F of the product of AB under F is the product of their individual images. So for example, G, say the operation in G is dot, and the operation in H is star. So a way of being specific is F of A times B, because the operation in G is a dot, is denoted by a dot. is equal to the product of their images under the operation in H. Ganun. So, okay, let's proceed to kernel. Kernel of groups. Kernel of groups, kernel of a function. Kernel of a function f. So, again, f is a homomorphism. Say homomorphism of groups. What is the kernel? Okay, so we have this is G, this is H, and we have a mapping F between them. So the kernel are actually those elements in G which are mapped to the identity element in H. So yeah, you collect all of those elements in G which are mapped in H, which are mapped in the identity of H. Identity of H. So how do you define that? So paano i-define? Kernel of F are all the elements A and G such that their images under F is the identity in H. So yun lang. That's the definition of kernel. Kernel. So yung mga elements sa G na mapped to the identity in H. Next term to define is the image. It's actually quite simple. The image of f. So again, f is a function mapping from G to H. So the image of f, okay, so ganito lang. So again, meron kang G, meron kang H, close dapat. G, H. So, function. So, i-collect mo lahat ng images ng elements ng G. Diba? Tapos, saan yun sila? So, I would say dito. So, this is the image of F. So, ito lahat. Collect mo lahat yung lahat ng elements dito sa G. Saan sila mapped sa H. So, collect mo lahat yun. Yun yung tawag na the image of F. So, ano yung definition niya? So, basically, yung image of F ay yung mga elements ng H na merong nagmamap na elements sa G sa kanya. Merong nagmamap na elements sa G. Elements of G sa kanya. So, image of F are the elements in H dito such that P is the image of an element A under F for some A and G. So, merong nagmamap na element ni A patungo sa kanya. Parang ganun. So, for example, so dito si B. So, dito si A. So, si A, nakamap kay B, di ba? Because B is equal to F of A. Ganon. Or another way of doing that is ganon. A is mapped to B. So, sometimes, para mas klaro, other people would write simply f of A such that A is an element of G. Ito, mas klaro. Yon, image of F. Hindi necessarily na lahat ng elements ng H ay nasa image because hindi naman necessarily na lahat ng homomorphisms ay onto. Pero kung onto siya, tawag doon epimorphism. So, mangyayari lang yun na the image of F is the whole group H if and only if F is surjective, meaning onto. Yun. So, ano pa? Congruence modulo H. Ooh, congruence modulo H. So, for the next part, because I forgot to use the right notation, so just replace, here I used A is left congruent to B. Just replace all of those by A is left congruent to B mod H. So this is congruence modulo H, and that will be explained in a while. So, meron kang group G. Tapos, si G's, meron siyang subgroup H. So, congruence modulo H. So, kung meron ka subgroup H ni G, pwede ka mag-define ng isang relation or congruence. Anyway, relation mo na. Ng elements. So, for example, meron kang dalawang elements, A and B sa G. Pwede ka mag-define ng start sang relation. So, sabi natin na si A ay related kay B if A inverse B nasa H. Okay? Actually, tawag dito left kasi ito lang. Left siya kasi yung left, yung A, yung nasa left, yun ang may inverse. Pwede ka rin gumawa ng right relation. Like A is right related to B if yung sa right naman ang may inverse. Diba? So, tawag dito is this relationship is congruence modulo H. Ano yan? This is guys, add image, add note, add text. May add text pala. Haha, I didn't even know. Okay. So, yun. Itong relationship na to is a congruence relation. Tawa ba? Congruence relation. Ano sabihin ng congruence relation? Ibig sabihin, satisfy niya ang RST. Reflexive, symmetric, and transitive. So, reflexive, ibig sabihin, A is focused sa left relation. No. A is related to A because why? By definition, um, A inverse A, but A inverse A is the identity, and obviously the identity belongs to H because H is a subgroup of G. Next, symmetric. If A is left related to B, then B is left related to A. Ayaw, hindi ko na-prove. Tapos, transitive, if A is left related to B, and B is left related to C. Parang gawing bridge si B. Then si A at saka si C left related. Ganun. So, congruence relation. Tapos, ay, ano nangyari? Oh. Nara. Okay, so since the congruence relation, then um, it defines congruence class. So focus sa left congruence. So diba, A left related, A is congruent to B. Mas gusto ko yung related kay congruent. Anyway, if A inverse B is in H, yung product nila na ganito, sa H. So, copy natin. A inverse B is in H. So, pwede ko mag-multiply ng A. Diba? Left. None. So, this is just identity, just B. So, meaning, B is in AH. Right? B is in AH. Let's check. They are sure. Tama. So, ito yung equivalence class. So, meaning, yung equivalence class nila is AH. AH, which is the set of all the products. AH such that H is in H. So, since A and B are congruent or related, then they belong to the same equivalence class. Equivalence. So, these are the equivalence classes. So, again, A, ayong red. Okay, collect it red. A is left congruent to B or related to B if and only if by definition A inverse B is in H. And this will happen if they define the same congruence class, or we call them cosets. Same coset. Tapos, collect all the cosets. So G mod n then is the set of all left cosets of M say n in G, right? So n is normal in G. Normal in G. I haven't really discussed normality. Maybe in another. I haven't really discussed normality yet. Does it have to be? Does a subgroup have to be normal for the left and right cosets to coincide, or for the left cosets and the right cosets to have the same elements? That's a question. So this is the definition of G mod n or G mod h, right? I think you can only define this modulo if n is normal. Why does it have to be normal? That's a very good question. Why does n have to be normal in G? Does n have to be normal in G for this to be defined? That's a very good question. Okay, so G mod n is the collection of all those cosets. All this distinct, just the distinct ones. Para dili magpalik-balik, walang paulit-ulit, walang duplicates. No duplicates. Okay? And then, what is the operation defined here? The operation defined is you have two cosets. Two cosets. Say you have two cosets, A, N, and B. And how do you define the operation between them? So basically, just their product is just this. This is their definition. Rather, the operation. Yun. So what else? Quotient group, done. Canonical epimorphism. Simple lang. So you have, diba? You have a group and you have a normal subgroup of G n. So you can define a mapping from G to G mod n. Let's call it pi. So how do you define it? So A is mapped to its equivalence class and epimorphism onto. This is an epimorphism. Because an element in G has to belong to some coset. Because, diba, a coset is either two cosets, say, two cosets AN and BN are either disjoint, meaning they do not have this intersection, they do not have common elements, or the same. And G is the union of all those cosets. So an element A has to belong to one of those because G is the union of all the cosets. So basically, it's partition. Parang ganun. Partition by the cosets. So that's definition of terms. Definition of terms pa lang. So next is we have to prove na the factor theorem. So to prove the factor theorem, again, you have to prove that this mapping is well defined. First of all, then it is unique. There's only one such mapping. And then you prove this, and you prove that, and then prove